Okay, let's start. So today we'll be speaking about 4 pillars of microservice-based applications in Kubernetes. So I'm Damian, and I work as a software architect. My responsibilities is to design solutions based on Kubernetes. I'm also helping development teams in migration their apps to the cloud and to the containers. Apart from that, I'm founder of a portal mostly focused on Polish community. We can translate it into in containers and also Docker School if there is non-Polish speakers. Also, I've started a podcast about a cloud-native world, but this is only for Polish community. I've also created some comprehensive courses, online courses regarding Docker and Kubernetes, and everything is hosted on my own platform. And recently, just this month, I've announced that I was selected as a Docker captain. So 2 days ago, there was an official announcement about that. And today on the Docker blog, you can find out, let's say, a kind of query with me about funny things in my life. Yeah, so that's it when it comes to what I'm doing. And let's focus on the agenda, which looks like how to prepare applications to be ready for the Kubernetes. I think it's most important things for developers. Especially when we are thinking about migrating from the VMs to the Kubernetes. Yeah, so this is a kind of different mindset we need to apply. How to embrace communication, logging, monitoring, and observability. And those 4 pillars of microservice-based applications we will cover today. Of course, we need some tools. So I will try to share with you some kind of tools that you can start with, or also which can be an example of tool, and so you can find out the best convenient for you. We will be speaking about one application because I believe the examples gives us the most comprehensive knowledge about the topic if we stick into one example of the application. Yeah, so there will be one microservice-based application. So let's start. And we will start from the most important topic when it comes to microservice-based applications, which is communication. So when we start designing our solution, our systems, it doesn't matter if we would like to deploy it to VM, to the cloud, or to the Kubernetes. We would need to prepare some mechanism that will allow to communicate with each microservice. Yeah, so this is something we need to carry on the source code. And in the next part of my session, I will try to present an example how to do it. Yeah, so what kind of communications we can have? So the simplest and the most popular is synchronous communication. Most often is there kind of request and response. It could be HTTP, but also nowadays the gRPC comes into play. And of course, asynchronous. So you can probably know about kind of tools like RabbitMQ and other message queues. So those kind of communications we will use in our demo today. So just a quick reminder, I know that most probably everyone knows the difference between 2 types of communications. However, just a reminder, on the picture you can see that if I'm calling someone, I need to wait for the answer, yeah? until somebody doesn't respond to me, I need to wait, yeah? So this is the most important when it comes to synchronous communication. In terms of asynchronous, I can send an email to you, and you can respond to me anytime. You can respond in 1 minute, but you can never respond to me, yeah? So that's the case, and we need to carry on with that fact in the case of microservice-based applications. So the next thing we would like to cover is where are we going to keep the logs? So each system needs a logs. That's something obvious. So this kind of, let's say, pillar, I call it logging, needs to be covered also in the source code. Kubernetes has some mechanism that can help you with logging. However, the proper design needs to be handled in the source code. I will show you in a while how to do it. So what are the options when it comes to logging? We can design it in this way that each microservice logs directly into external system. So now the popular is Elasticsearch, it could be Splunk, or even it could be database. Yes, so we can decide to which system we will send the logs directly, and the logic will be implemented in our code, right? Of course, it should be configurable, like we can pass the connection to the system which you would like to send the logs. Another option, when it comes to designing the systems, it could be designed in this manner that our logs will go to the std out. So having this allows us to aggregate all those logs by some additional tools, and this is, to be honest, very popular approach when it comes to containers, Kubernetes at all. Also when it comes to cloud Kubernetes versions. And most of the cloud Kubernetes versions already have some dedicated tools that we can just use without any configuration. It's just in the pack with Kubernetes. And I wanted to give you one important message, which you should keep forever when it comes to everything which is related to containers. We do not log into local text files. This is, let's say, a kind of obsolete approach when it comes to VMs, where we had a log file, a big log file, and everything goes to this one file, or even multiple files, for instance, separated by each day. Yeah, so we have separate txt file with the date in the naming convention, right? So this is not the case when it comes to Kubernetes, the cloud-native world. So please remember, do not log into local text files. Why? Because this is how we should change our mindset when it comes to containers, when it comes to Kubernetes. So containers is something that can be in our system for seconds, and it can be gone anytime. Yeah, so this is something ephemeral. Yeah, so you shouldn't keep it as a constant thing like we keep it the VMs, for instance, right? So we should do not log into local text files. Yeah, so the next step when it comes to the road from source code to the Kubernetes is preparing the Docker files. Yeah, so Docker file is a kind of text file where we are defining how to package our application and what we need to run that application. What dependencies, what libraries, and anything else that our application required to run correctly. Everything should be included in the Docker file, yeah? So once it's built, once the image is built, like we are going to the next step, So once the Docker image is built, it should allow to run the container with parameters. Yeah, and what kind of parameters? For instance, it could be connection to some external systems, right? Our applications can rely on some external systems, and depending on the environment, the configuration can be different, right? So we need to pass it as a parameter. Going to the next step of our road to Kubernetes, we need a place where we will be storing the images. Yeah, so as we do for non-containerized containerized workloads, we need to also carry about versioning of our Docker images. And finally, once we have those previous steps completed, we can think about deploying it to Kubernetes. Of course, there are, let's say, some additional steps when it comes to automation, security, and stuff like this. I wanted to take a look on the one slide on this approach, and to not complicate too much the sentence of road to Kubernetes. However, I will back to this point at the end of my session. Of course, we do not create pod as an object directly. We are using some high-level components, let's say, high-level Kubernetes objects that help us with running our applications in Kubernetes, which help us with scaling and managing the release life cycle. Okay, so we went smoothly to the next pillar, is the monitoring. So why monitoring is important? Yeah, so when it comes to Kubernetes, which is a special architecture when it comes to deploying the applications, we need to carry on about if individual microservices are alive. How much compute resources do they consume? Why it's important? It's also a kind of a blocker for something we do not expect in our systems, right? So in case the container consumes too much memory and, for instance, consume all the memory we will have on the one VM, it could go to the downtime of particular VM. Yeah, so we need to carry on about compute resources containers consume. And of course, metrics. Yeah, so the capacity, the average response time, handling the errors, how our applications behaves in case of 404 error and stuff like this, right? What kind of tools can help with this? Yeah, so we have a lot of options, and today I will give you an example of open source Prometheus. However, you can really choose from various options on the market, also the paid tools, which you can see on the slide. But this is not the end of our important things when it comes to deploying the apps into Kubernetes. Of course, we should carry about observability, aka distributed tracing. So this is, I think, the most important thing in microservice architecture at all. So we should be able to track the request flow through the system components. Yeah, so let's imagine we have multiple microservices, yeah, and we would like to debug it. Each microservice communicate with each other, and how to check at which stage something went wrong. And the observability solved that problem. Example, somebody is using our user interface and, let's say, ordering a food or, I don't know, cinema ticket. Of course, we have this microservice architecture. Yes, so how to validate what was wrong during the request life cycle. Yeah, so observability can help with this. We have two standards approaches regarding observability. It's OpenTelemetry and OpenTracing. There are also multiple ways to do that, and there are multiple tools which can help you with this. And today we will be using Jagger. How it can look alike? Yeah, so this is a screenshot from Jagger, and on the screenshot you can see the request lifecycle from the front end till the Redis cache. So the full flow of the request that went through the system. Those kind of tools can be integrated with databases, can be integrated with queues and stuff like this. So we will have the overall look of entire request flow. So this is one example of cloud native app. So usually it's divided into front end part, into the authorization, into secrets, into airbag, and some kind of storage. Yeah. When it comes to Kubernetes, we should look at this as a platform that allows us to deploy, scale, and maintain the application lifecycle. Now the question, who had heard about 12-factor apps? Can you raise your hands? Okay, thank you. So those 12-factor apps principles also can help you with starting with the Kubernetes. I've selected, in my opinion, the most important, strongly connected with the Kubernetes. So let's start. First principle is everything in code. And let me give you an example. So we have the Docker file in our Git repository. So based on this Docker file, we are building our Docker images, which goes to the container registry. Second example, when it comes to Kubernetes, we are storing our Kubernetes manifest or Helm chart files in the Git repo. And based on that, we are deploying our apps to the Kubernetes cluster. The next principle is configuration using environment variables. Example, the DNS or URL to the backend service or to some external service that our application use will be passed as an environment variable. Yes, so it will be customizable according to the environment, like dev, test, prod, and stuff like this. Yeah, so we should prepare our applications during the design phase to allow passing environment variables. The next thing is data storage in external services. Yeah, so we do not store the sessions, user sessions, in application memory like .NET, Java, or any other technology, but we are moving it to the external service like Redis cache. The next principle, most important, in my opinion, of course, you can have a different view, logs as a data stream. And that's something we already covered, that our application should logs to the std out, and then the logs can be consumed by some external system. So what we have already covered seems to be simple, especially when you take a look on some tutorials, blog posts, and stuff like this. Yeah. Who ever seen this kind of comment? Yeah. It's everywhere. Yeah. So it's everywhere. This comment is everywhere almost. The same stuff for BusyBox. So you want to use Kubernetes, just run kubectl, run busybox, and that's it. And what is my view at these tutorials? Yeah. So when the real projects comes, it's not so easy as you can imagine. So I would like to introduce the application we will use as an example to present you some of the details how to prepare our applications to be deployed in the Kubernetes. So first of all, business assumptions. The application should allow us for customer management, for ships management, and workshop slash maintenance of the ships. Yeah, I forgot to mention what the application is about. Application is about maintaining ships, preparing ships workshop like this. Yeah, so this will be the basic functionality which we will implement, like sending notification to the customers, invoice sending, and other stuff. The application should be scalable because it will be the SaaS model. So we believe it will be used by many shipyards in the world, and we can expect a huge traffic. It should be ready for development, and one team of developers could work on a certain part of the system and the other on another part. It should be cloud agnostic because it's not yet decided where it will be implemented. So here's the architecture. We'll have the customer management module, ship management, and workshop management, the three core components of the system. Each of these components will have its own database. And the third component, like workshop management, will be divided into two separate components. It will be API part and event handler part, because we will use asynchronous communication using RabbitMQ. The basic architecture looks like this, so please take a look. So how it will look like. So we will be communicating using RabbitMQ and also using synchronous communication using HTTP. So events will go to the RabbitMQ from those two core components, and components below will be a kind of consumers. Of course, we need a user interface, so I call it frontend, where users will be reaching out to our application. This application is available on the Docker Hub, so I mean the Docker images of this application, so you can take a look. And when it comes to communication, as I already told it will be HTTP plus asynchronous using a message broker. How it will look like when it comes to Kubernetes implementation. So I've tried to draw some Kubernetes internal components, which we'll be using directly in the Kubernetes. So communication will be based on cluster IP services, so internal communication between three core components. Also, the flow will be going from the front end through those cluster IP services. And now time for asynchronous communication. So our three core components will be sending events to the RabbitMQ, and 4 of them will be a consumer. Also, you can take a look on the object which we have in the slides. I know it's probably small, and but I can quickly describe. So each of component will have the cluster IP service, the deployment or stateful set, depending of if there is a stateless or stateful application, and also the basic objects like pods. Of course, there will be more advanced objects, maybe not more advanced, but specific objects to specific component like secret, config map, and stuff like this. So now let's take a look in code. Before I jump to the code, just a quick reminder, it's not, let's say, the production-ready code. I wouldn't like to complicate the code, so I removed all the stuff like best practice of security, because it will be hard to understand for the beginner in the Kubernetes world. So just a reminder. So we have this service. So I told that each component will be cluster IP service. This is the web app. The port is 7000, and we have deployment. So deployment is the object which aggregates the pods. And now, in case of communication, this is the most important thing. So we have the environment variables, which we are using to pass the configuration to the particular microservice. For instance, we have customer management, we have ship management module. So from the front-end part, we are passing those values to the front-end part. We are passing those values to communicate with other microservices. Everything is working using environment variables, which we are preparing before actually deploying the app to the Kubernetes. The same thing for the Jagger. Yeah, so we have environment variable which we are using to inject the URL to Jagger. Now let's take a look on the customer management API. Yeah, so we have this port, and if we go back to the web app, you can see that this port is specified as well in the environment variable. Yeah, so in this way, web app can communicate with customer management API and other modules. Okay, so let's now jump to the next topic, which is logging. Yeah, so in that example, all the logs goes to the std out. So we can read them using simple command like kubectl logs, but we will use the fluentd agent, which will be deployed on the Kubernetes cluster, and it will constantly monitor the logs that are coming from the all microservices, and it will be uploading them to the Elasticsearch. Then we will be using the Kibana to query the logs in a convenient manner. Yeah, so it looks more or less like this. And time for another demo. So we have delogging, right? As you can see here, there are few YAML files which are used for deploying the Elasticsearch, the fluentd Kibana. Yeah, so we can start from the Elastic. Just a reminder, it's not a production version. It's a kind of, let's say, demo for not complicating the case. We have the fluentd agent, and of course, we have the Kibana. So using the Kibana, we will be querying the logs from the browser. Yeah? So now we are going to the terminal, and we are querying what objects are in the logging namespace. Yeah. So as you can see, there is Elasticsearch pod. There are 3 fluentd pods because our cluster consists of 3 worker nodes. On each worker node, there is one fluentd agent, which aggregates the logs. And we have finally the service like Kibana. So using the kubectl port forward, we are allowing to access the Kibana from the cluster, because by default, it's not accessible outside our Kubernetes cluster. So we are redirecting the traffic from the cluster to our local computer, yeah? And now if you go to the browser and hit the port we have redirected, Kibana started to load. It takes some time, but in the first step, we are creating the index pattern, and we have, as you can see, multiple existing proposals for each day, but we will make it generic to see all the logs that were generated on the cluster. So now creating the index pattern. So meantime, again, Fluentd works on each worker node. It sends the logs to the Elasticsearch, and Kibana connects to the Elasticsearch, and we can view those logs of the entire cluster. Yeah. So this is one of the common cases when it comes to configuration of production systems. At high-level stage, at least, yeah. We are not talking about the YAMLs, yeah. But in case of high-level architecture, it's a kind of one example, yeah. The next thing is monitoring, yeah. So our application should have some kind of endpoints like /health or /ready or anything you want to name it, which will be used by Kubernetes to check if our application is alive or to check if our application is ready to handle the traffic, yeah? Because sometimes our application seems to be ready because the pod is running. However, it's not ready to handle the traffic from the users because some processes, some kind of initialization still take place. So this is important thing that each application should have that endpoints implemented during the design phase. And now we'll be using the Prometheus stack, so like Prometheus, Alert Manager, Grafana, and stuff like this. And the architecture looks more or less like this. So on our cluster, we have the Prometheus node exporter, which works in a similar way like Fluentd agent. It works on each worker node. As you can see, there is a daemon set object which handles it. And this Prometheus node exporter will transfer the metrics, the information about how many resources our containers are using and stuff like this. And finally, we will be using Grafana to visualize those metrics and those resource usage. Okay. So we are closing the connection with Kibana because this is the port forward. And we will go to the Grafana right now. Yeah. So we need to find out what kind of objects we have in our cluster in the namespace monitoring. As you can see, 3 node exporters, the same like Fluentd. We have the Prometheus server, which is, let's say, the central place for aggregating the metrics. And we have, of course, the Grafana, which we will be using for a fancy dashboards. So in the same way as we did for Kibana, we will be doing the port forwarding. But before that, I would like to show you how I've prepared this kind of Prometheus stack. So I've used Helm, and you can try with this. This is more production than my YAMLs when it comes to logging, like Elasticsearch and stuff like this. So I highly recommend to use Helm charts, for deploying some external tools that which you will be using on your clusters. And now we are going to do the kubectl port forward, which allow us to see the Grafana UI in the browser. Yeah, so we will be doing the same thing as we did for Kibana. We are forwarding the traffic from the cluster to our local port 8084, and 80 is an internal service port inside the cluster. Okay, so forwarding starts, and now we can go to the browser and change the port to the 8084. Okay, so Grafana loaded, and now we are going to type admin and the password we provided inside the Helm install command. Yeah, so this is my password. I've injected into the Grafana, and now you don't need to be an expert of Grafana. You don't need to know everything about creating the Grafana charts, because you can import already prepared and quite nice charts / dashboards. This is the one example. We need to select the source of our metrics. We are selecting Prometheus, of course, and just import, and in a few minutes we have built the nice dashboards which present what already is going on our cluster. Like, we have the network pressure, we have the cluster memory usage, we have the CPU usage, of course, and all the metrics which are important when it comes to cluster and application monitoring. We can also view how many CPU each container is using. And in a while, I will show you the Elasticsearch funny thing, because Elasticsearch deployed on the Kubernetes, and I believe deployed anywhere, consumes a lot of memory. It's more than 1 gigabit. So it's kind of heavy tool. Yeah, that's not the end of the Grafana stuff. We can also import different dashboards, which are already prepared, and you can just import it and use it for your reference. So we are selecting again the Prometheus, and another dashboard appears. Yeah, so we have we can see here how many replicas we have, how many containers are running, how many jobs succeeded, and stuff like this. And of course, this is, let's say, a kind of introduction to Grafana, because there is more things we can do. Now we will use the simplest monitoring, I can say. So this is the kubectl top command, and you will see just in the command line how many resources each pod is using. Yeah. So this is, let's say, the minimum monitoring which we can have. Now we are going to the observability part, which is, I think, very important, and maybe you didn't heard about it. So we're using the OpenTelemetry standard, which is implemented on the application side. So on the application side, there is important a library which integrates with Jagger, and the logic is implemented in the code. Yeah, so this is not something which Kubernetes can handle by default. You need to prepare it before the deployment. So it will look like this. So our application is ready for injecting the connection to the Jagger, and we will be injecting in our YAML files. There are a few components which are deployed on the cluster, and from our perspective, we will be using Jagger UI just to verify the request flow during our system. So we are starting from querying what kind of pods we have. So we have all those components of the Shippy application, and we have here the Jagger. So we will be using, again, the port forward to route the traffic from the cluster into our local machine and to be able to reach out to Jagger UI from our local machine. So the same way, port forward and forwarding the traffic into the same port on our local machine as the Jagger SVC is working. Yeah, so now going to the browser. And this is the Jagger UI. So automatically you can see that we can query particular component. However, I'm opening the new tab, and we will be forwarding the traffic from our Shippy web application to present you how it looks. It's of course the most important thing, how our application looks, how our application looks like. So again, the same approach. Using port forward, we are routing the traffic from the cluster to our local machine. Okay, so it started, and now we can go to the browser and just type the port we selected. So the Shippy application looks like this. It's very simple. So what now? So we are going to add some customer to our system. Yeah, the best name would be, of course, test. Same for the address and postal code. And now some front-end developers will comes in and tell me that there should be a validation, and I shouldn't be able to pass test as a phone number. Yeah, you are right. But I've never been a front-end developer, so sorry for that. And yeah, so we added new customer. Now we will be adding a new ship to our system, and we are using some fancy names and saving this to the system. Now we are planning the workshop. So what we need to do with our ship on the workshop? Yeah, it will be Devoxx presentation. Okay, so we had to input those data to show you how the observability can look like. Yeah, so once I refresh the Jagger, now I can see more inputs to select. And first of all, I'm selecting the web app. Yeah, so I can query the request flow which went through the web app. So I'll go to the longest first. And first of all, there is some errors which occurred in our system. Yeah, on the front end, nothing happens as you can see. Yeah, what is important here? We are able to see to which URL the traffic went through. And if we go to another component like Workshop Management API, query to the longest first, and you can see the entire or almost entire request flow because there is no database and because I didn't manage to implement it. But it's also possible to see in this entire, let's say, Gantt chart, how the request goes to the database, how long it takes to save the data into database and stuff like this. And now you can see each request step by step, and basically the history, how we planned our workshop, yeah? So we planned our workshop, and during this clicking the save button, all that stuff happened, right? So with observability, you can track it, which is the most important in case of any debugging, of any issues you spot in your distributed microservice system, yeah? So there is another example, like what happened during the particular request, yeah? So wrapping it up, when it comes to the Shippy application, we have a lot of additional components, yeah? We have the monitoring using the Prometheus stack. We have also the observability part using Jagger. And we have delogging implemented using Fluentd and Elasticsearch and Kibana, yeah? And just a quick reminder, if you are using the cloud-based Kubernetes, most of the cloud providers already comes in with dedicated logging tools. Like in the AWS, there is a CloudWatch. You can leverage it to integrate it with aggregating the logs from the Kubernetes. In the Azure, there is a log analytic workspace for that. So you don't need to care about installing the Fluentd, Elasticsearch, and Kibana. You have, let's say, in the cloud-native mechanism which we can use. Yeah, I wanted to present you some kind of, let's say, generic example which you can deploy anywhere, even on your local laptop, on the Docker desktop, Rancher desktop, Minikube, and stuff like this. However, when it comes to the cloud-based Kubernetes, most of that stuff is already in place. You can just use it, and I will recommend that approach, because managing the entire components like Elasticsearch and Prometheus stack, it's not an easy thing. So I would recommend to use those cloud-native tools. So the example architecture looks like this. So as you can see, it's not easy to deploy a microservice-based apps in Kubernetes. However, it's not all we need to know before we decide to move to Kubernetes. Yeah, because we haven't covered how containers work under the hood. And I think this is a must to understand various mechanisms which works in Kubernetes. Yeah. The next thing is secrets and configuration. So how to store sensitive data in Kubernetes. I can tell you that the default mechanism called Kubernetes secrets, it's not the best approach, at this moment at least, because the secrets are not encrypted. Of course, the security. We haven't covered anything about security because we don't have so much time, both about containers security and both in the Kubernetes as entire platform. Automation, yeah, so CI/CD, GitOps, what is canary release, what are benefits of those approaches like canary release, blue-green deployments, and stuff like this. Yeah, so this is a lot to learn when it comes to deploying the workloads in the production on Kubernetes in the containers. Just a reminder, whenever you decide to do that, please deep dive into those topics which I mentioned here at least, because in my opinion, they are the most important when it comes to the production workloads. So that's it from my side. Thank you very much.